Insight webinar talking about an improved method for controlling brown stock defoamers in pulp mills. My name's Tom Hayden, and I'm Solenis Global Marketing Director for our Virgin Pulp Group, and I'll be facilitating today's call. Before we get started, I'd like to cover some basic housekeeping items. This webinar is being recorded, and a copy will be shared on solenis.com. We do request that people please mute their phone lines during the presentation to minimize background noise. And finally, there will be time for Q&A following the presentation, but questions can also be asked during the presentation in the chat window. We'll be monitoring that and try to answer those questions along the way. With that said, please allow me to introduce our speakers. We have two speakers today. Harold Petke is a Senior Technical Advisor in Solenis Pulp Applications Group. Harold received his BS and MS in Paper Science from North Carolina State University and has over 38 years of experience in the pulp and paper industry. He's been a frequent presenter at conferences and has contributed to several TAPI publications. We also have Scott LeGrand. Scott is a Pulp Applications Manager in Solenis Pulp Applications Group. Scott's a chemical engineer and pulp and paper graduate from North Carolina State University with over 32 years of experience in the pulp and paper industry. Scott's experience also includes time as a pulp mill production manager and in pulp specialty sales prior to his current role in Solenis Pulp Applications Group. At this time, I'll hand it over to Harold Petke to kick off our webinar on an improved method for controlling brown stock defoamers in pulp mills. Harold?
Good morning, good afternoon. It's really the key here today is we're looking at a solution to drive more value from existing programs. And just to set the stage, in general, we look at 3 R's of value delivery, which all need to be in place to maximize the value of any chemical program. That includes the right chemistry. And generally, there are multiple opportunities or multiple options for a given problem relative to the chemistry. So selecting the most appropriate chemistry is the starting point to get the right chemistry for the issue at hand. But just as important to that is making sure that chemistry is applied in the right place. The application is crucial to making the chemistry work, and understanding the chemical interactions that take place as well as process characteristics is extremely important in the effective implementation of any chemical solution. And finally, the right amount. It's obvious that over-applying has direct economic implications to any program cost, but also making sure that there's adequate quantity being applied at all times has direct implications on performance. So making sure that the right amount is being applied as the process changes and as the conditions change is key to the ultimate delivery of value. Putting all of these together is how we deliver maximum value to a customer. So what we're going to talk about today is really focusing on the right amount. So we're looking at how do we maintain the appropriate dosing of a defoamer to a process at multiple points. As the process changes, as the demands change, as there are process upsets, and as there are varying needs throughout the process. So there are many defoamer feed strategies and philosophies in use today, and they range from a very basic set it and forget it manual control to more advanced multivariate controls. But by far, the majority of applications fall somewhere in between. Most of these in-between control strategies will typically ramp all of the feed points together, whether it's based on production rate or an auxiliary input such as entrained air or conductivity. Now, these approaches certainly have merit and are significantly better than the set and forget approach, but they also have very significant limitations with respect to providing the right amount to each feed point all of the time. Solenis' SmartWash program is designed to look at specific performance indicators for each application point and control the dosing independently. So each pump delivers the right amount for that location regardless of what the other application points need at any given time. Now, SmartWash is not a defoamer, a washer control program, but it is a defoamer control program. So it's not going to change the way that a washer is controlled or reacts, but it is going to modify the dosing of the defoamer to maximize the performance of the washer. It utilizes real-time DCS data to make changes and stay ahead of major swings and upsets. It can also be adapted to work with a wide range of different equipment, different washers, chemi washers, vacuum washers, DD washers. It doesn't matter. The strategy can be implemented for all of these different types. It can also integrate auxiliary inputs, whether they've been put into the DCS control system or not, such as localized entrained air measurements or conductivities or black liquor solids or density meters. We can also input these auxiliary data points into the algorithm. And essentially, it integrates with the mill DCS so that the operators will always have final control over the program. If they need to go into manual control for significant upsets or startups or shutdowns, they still have the same control and ability to do that as they do currently. So really, what is it? It's an advanced control program that we are looking at. Sorry, this thing's not moving right. Here we go. It's basically a digital operator where instead of having to rely on an operator's focus to make changes as the process is moving in a certain direction, this is a digital operator that's constantly looking at the process and understanding whether it needs more or less defoamer in a given application. So we eliminate shift-to-shift variability as well as operator variability. As they get focused on other things that are going on in the process, they don't have to be distracted by making changes to the defoamer program. So in essence, it reduces some aspect of washer variability. It also will reduce or minimize defoamer cost. While that's not necessarily the sole driver here, whenever you get defoamer control to the point that you're keeping the right amount on, overall the defoamer usage will go down because you're not overusing and certainly not using high levels of defoamer for extended periods of time. The other option that this allows is to control multi-component programs. So the incorporation of a secondary defoamer or a wash aid or drainage aid can be incorporated in the program design, and that would allow two separate programs to be run independently, but with similar overall washing strategies in play. In addition, it has the ability to set guardrails where no matter what is going on in the process, minimum defoamer levels can be maintained and maximum defoamer levels can be capped. So how does it work? Really, we're pulling real-time DCS data into an algorithm that is looking at multiple feed points and the KPIs associated with those feed points to understand how much defoamer is really required at any given point in time. So it allows us to independently control multiple feed points by looking at what's really going on in the process and not relying on a single input or a very limited set of data inputs or operator control. It's a way to have an automated operator constantly watching the defoamer pumps and defoamer demand and making appropriate changes continuously, as opposed to making big changes when after something has happened and putting the process into a reaction mode. So if we look at what really goes into the algorithm, it's going to vary from location to location and mill to mill based on what type of equipment is being used, what the KPIs for that equipment really are, what the washing strategy is in a mill, whether there's a push for maintaining higher black liquor solids or there's a push for reducing conductivities or COD carryover. The program will be set up to work with the mill's washing strategy. So these are customized programs, and every one is going to be a little bit different based on a mill's equipment, their strategies, and their capabilities. But there's a host of data and variables that can be pulled in, and each one will be specific to the particular application point, such that a point that is looking just at maintaining surface foam control is not going to be necessarily focused on what the final conductivity is coming off the washer. And each variable for each application point can be independent and different, although there's also the opportunity for global variables that will influence all the pumps to some degree. So really the key message here is that these are customizable programs, and they will be tuned to exactly what the specific requirements are. These are not black box plug and play systems, but they will focus on the real needs and the real goals of a particular application. So briefly, I wanted to give a couple of examples before Scott goes into more of the details about what's behind the programs and what's required to get them working. Just to give you an idea of what we've been able to achieve with the SmartWash algorithm. This is an example of a mill that was running a two-part defoamer washing program. One was a typical defoamer, the other was a drainage aid that was only turned on when they were trying to meet their conductivity target to the bleach plant. So the mill had an in-house defoamer control strategy, and then the operators would manually turn on the drainage aid when they needed to improve their washing and hit their conductivity targets. The algorithm for this application was fully implemented in 4 days, which was fairly quick for these things, but there was a lot of buy-in from the operators. The result was that 15% reduction in defoamer demand with the implementation of the algorithm and 50% reduction in drainage aid. And the drainage aid was very significant because as the defoamer control was improved, there were fewer upsets, so there was less demand for the drainage aid. They had fewer opportunities that they needed to turn it on because the conductivity got out of hand. And the other influence on reducing the drainage aid so much was the fact that when the conductivities were back in control, the system turned the drainage aid off, as opposed to waiting for the operator to realize or remember that he still had it pumping. So there's very significant savings in this application. Another example, excuse me, was a multi-line mill that had 3 independent wash lines. And it was a little bit more complex, but there was an independent control set up for each one. And this was a two-part transition where the initial transition was just swapping over from an incumbent defoamer to a Solenis product. And there was significant savings that were realized just from the defoamer change. Once the implementation of the SmartWash programs were in place, they replaced the mill's in-house defoamer control strategy. And an additional 9% savings, which for a mill that was this large was still very significant, were attributed just to the change in controls. Now, as a note of how flexible this program can be, since this was installed, the mill has changed their washing strategy. And as such, we've changed the algorithm in the mill. They're now much more focused on increasing production at higher black liquor solids loading. So their strategy and focus has changed from cost savings to maximizing production. And the SmartWash program has allowed them to do that seamlessly. So just a couple of examples of what this technology can do. Now I'll turn this over to Scott LeGrand to walk you through how it goes together.
Yeah, so Harold covered, what it's going to do, and what we're going to look at now is kind of what's behind the algorithm and, what we have to do to put it all together. All right. Hit the next one there, Harold. Really the backbone of our system is our on-guard eye controller. And it's, what it is basically a mini DCS that piggybacks onto your DCS system that runs our algorithm. It's very flexible. It'll take analog or digital I/O. And it has a lot of connectivity options. Modbus is preferred, but we can take others. When you get down to hardwire, it does limit the system flexibility, some. So, most people can deal with Modbus with the modern DCS. And the good thing about it, it has remote logging and alarming capabilities. So it allows the system to send out text to our local reps or to mill people, in case certain set points are hit or things go down. Anything that you want to alarm to make you aware that something's going on while you're not at the mill. All right, next one here. Some of the system requirements, there is some level of automation that, that needs to be there to really utilize all the capabilities of the system, with the minimum really being that level control. Manually operated systems, will really yield limited returns. So, having some automation is what we really need to see the benefits. The key to our algorithm is accessing real-time data from the DCS. So like as Harold mentioned, we can, make a lot of changes. It's looking at it continuous, so we can change on the run to make the defoamer application as efficient as possible. So, being able to connect is, critical. The other thing is having a defined washer strategy, whether it's, production, defoamer reduction, cleanliness, higher black liquor solids. We need to know that going in so we can, design the algorithm, for the mill's needs. Then lastly, the feed equipment needs to be where it can be controlled by the DCS or the on-guard eye, which means it needs to take 4 to 20 inputs, or pulsed inputs. So, if the current equipment doesn't have that, it may need to get some new. Data communications, you know, like we said, Modbus is most flexible, and most of the time that's the easiest thing to hook up with, being that it's just one wire. You know, we can accommodate other, but you know, like we said, it may limit some flexibility. You know, minimal DCS programming from the mill is required, and most of that will be in the operator interface page for the defoamer. So, you know, may need a defoamer page created or modified to, you know, do the start stop, see what's going on in the system. And there'll be some coordination between Solenis and the mill, you know, to set up registers and, you know, the normal DCS stuff. You know, some cabling will be, you know, needed to be run along with some 110 power to the unit. The next thing is the eye controller needs some kind of communication, you know, outside the mill, be it wireless or internet. The on-guard eyes come with a, you know, with a cell, you know, a cellular capability. So, you know, it either needs to have good cell signal where it's placed at or run through the mill's internet. You know, lastly, the defoamer pump configuration. And this is talking about whether the DCS controls it or the on-guard eye controls. And it's up to the mill. We can work that either way. You know, and like I said on the equipment, you know, we can control through the eye controller, so we can have the pumps directly wired to the eye controller. You know, if you got a new skid, it's a really remote location, you know, that can work. And a lot of mills like controlling the pumps through the DCS just so they have ultimate control over the pumps no matter what. You know, and what we like is to have the system where the pumps have a flow indication, you know, be it flow meters, you know, mag meters, you know, gear pumps, you know, gear meters, or they can have a flow indication as some of these new pumps have. And both of those work equally well. You know, and ideally we want one pump with a single head on it going to each location. And that allows the program to, you know, control each pump and dose it up and down. If you have one with multiple heads on a single point, you know, you don't get the precise control that you would like to have with this program to optimize defoamer application. And we always have, you know, manual capability in case of any kind of communication failure, or the operators need to take over in, you know, in case of something out of the ordinary. And this is what we were talking about with, you know, the pumps on the configuration options. And this first one shows that the pumps are, you know, wired to the DCS, and the eye controller is looking at the information from the DCS, running it through the algorithm, then sending a set point back to the DCS to relay to the pumps. You know, the next option is to do it where the pumps are controlled right through the eye controller, you know, wired directly to that. The eye controller looks to the DCS, you know, gets the information, runs it through the algorithm, then sends a set point back to the pumps. You know, an installation, you know, the location of the eye controller, it really depends on how you want to control the pumps. If most people find it convenient if you're wiring the pumps to the eye controller to locate the eye controller close to that skid, you know, then run the cabling to, you know, the Modbus connection to the eye controller out in the field. But if the DCS is controlling the pumps, really your flexibility with the location of the eye controller is where you really want to be convenient and minimize your cost in cabling. The only thing we need to have is make sure that our sales rep can have access to the eye controller. So putting it in an MCC, you know, may be an issue. You know, next thing is 110 power and the communication cabling to tie into the DCS. So pretty straightforward there. You know, startup, and this right here requires a plan. You know, what we ask is that, you know, before we start this, is we optimize, you know, our application points. As Harold talked about before, it's, you know, it's putting stuff in the right spot, you know, for success. So once we have optimized the application points, we can do a transition plan and, do our program, do the transition plan. And this transition is to move from the old setup to the new. And part of that is operator training, is to make sure the guys, your operators understand, what the program is going to do, what its responses are, and that they can always take over if they need to, then put it right back into auto. It gives them a security feeling that, hey, they have control. We like to run this program in the background, for 2 to 3 weeks at least, to make sure it sees a range of operating, scenarios, and that the system is making the appropriate response. So we'll monitor that, make sure it looks good before we turn it on live. Then also the algorithm will phase in some of the functions. We'll start up at basic pound per ton, get the operators comfortable with it. Then we can start putting algorithm functions in to gradually implement the whole program. And as they see that it's, a lot of this is confidence with the operators. When they see that it's actually helping them and they don't have to monitor it that much, it builds confidence, and we can optimize and gradually put all the functions in, to turn the program, fully on. So, back to the 3 R's that was covered earlier. We're going to get the right chemistry, the right place, and with the SmartWash, we're going to have the right amount, so the mill can, maximize the value of the Defoamer program. So now we have questions. And Tom, is there anything in the chat?
No, Scott, I haven't seen anything in the chat so far. So yeah, we'll open it up and just ask people. They can either ask the questions in the chat window or just unmute, and feel free to ask us live at this point.
Hey guys, it's Brian down in West Point. I just wanted to kind of get your thoughts. What are some of the strategies to help overcome, the black box fears and with operators to build that confidence up front?
A lot of it, Brian, is, slowly phasing in. It's training, is telling them what to expect. Then the next one is phasing in the algorithm and slowly build. Once they see that, we'll start in pound per ton, then slowly work their way up. And once they see that, they'll gain confidence on every step.
Yeah, and I would add to that, Scott, that part of this process is understanding what the operators are reacting to before this is put into play, what they typically look to the defoamer to do, what kind of upset conditions that they get worried about, and incorporating as much of that into the strategy as possible when it's initially built. But then it's still kind of a learning curve too. If there are things that the program doesn't react to that the operators need it to react to, then that can be adjusted for. So they're part of the process. They're the ones that ultimately are going to turn the program off if they're not happy with it. So we need to make sure that the program is giving them the response and the results that they need and expect out of the defoamer.
Yeah, and let them know they have a voice in it.
Can you hear me? This is Stuart.
Yeah, Stuart, we can hear you. Go ahead.
Great. Hey, so thanks for the presentation. Like, of a typical brown stock setup, what percentage of your application points are actually controlling a variable versus just on like a pounds per ton dosage? And how often is the algorithm just there for like a worst case scenario versus actually just controlling, a certain PV, I guess, if that makes sense?
I don't know that we can give you a number because every one of these is different. There are particular points that really are best controlled just in a pound per ton or just based off of a single variable. So there's not a given formula for what every system is going to do. It really depends on what the needs of that system are and the capabilities. So if you don't have reliable KPI indicators for an application point, then you're going to be very limited in what you can use to influence that particular feed point.
But all the defoamer points are put into the algorithm and monitored to, track your total pounds per ton. Even like as Harold said, sometimes it's just, best to just put it on a pounds per ton and leave it, but then the rest of them swing with whatever your KPIs are doing through the system. Did that answer your question, Stuart?
Yeah, did some of my observations is that some of the things that you're trying to control to are hard to know and when to, I guess, increase. So, just trying to understand some things are physically out in the field that you can't observe from a DCS, from a process variable.
Right, and those are the ones that the capabilities of the program are limited by the viable data that's available. So if you're trying to control surface foam in a sewer that has no inputs or indications that sewer foam is high or low, it's going to be much more difficult to get value out of a program like this. But if you're looking at subtle changes on a washer that can be influenced and measured, then that's where the value comes in.
Good question. Do we have any others or follow-ups?
Hey, this is Alex Taruba. I was kind of going to comment on that a little bit, but do y'all have it set up where basically one KPI controls one pump almost? Like you can set it up where like each individual pump is related to some other KPI. Like if you're talking about at the beginning of a washer, you're looking for drainage, you could set up the pumps in the front to look at drainage, and then maybe later on you're looking at foam level throughout.
Yes, every one of these we can set up independent and multiple KPIs for each of the application points. That's really the beauty of the program, is that we don't have to control in a broad brush stroke, that we can really focus the controls based on what's really important for that application point.
And some of them are, some points are controlled by that washer. If you have, say, a typical 3-stage brown stock washer, some are influenced by that single stage. Then there's some global ones that'll adjust all of them. It, depends on the KPIs and what the mill wants.
Good question, Alex. Thank you.
Hi, this is Brent here from South Africa. I just wanted to know, are there any limiting conditions or any conditions a mill has to meet to have this equipment installed? I'm not sure if that makes any sense, but the application size, for argument's sake. And then obviously who carries the cost of the installation of this? And does this unit, does it remain Solenis property? Is it amortized? How does that work?
Well, I think as far as limitations, it really comes down to this is not going to be a fit for every single application out there. And Scott went through some of the key criteria for what we need to have in place before we can even implement the control strategy. As far as cost of the unit and who owns it, we don't sell the unit. We don't sell the iController nor the program. That remains Solenis property. The overall installation costs and any other, monetary influences or considerations really need to be taken up individually with the local sales team and the mill to understand what the full package could look like.
And that's probably a good lead in. If anybody does want to, has questions that don't get answered here today, would like to get more details or set up a separate call for your specific mill site or your specific organization, we are certainly happy. You can send me or Harold or Scott an email, and we'll follow up with you to make sure we get that set up.
All right, thanks.
Good
Hey,
question
Tom.
so far. Yeah, go ahead.
Yeah, this is Gurudis. Scott and Harold, that was a very well done. The presentation was very well done. I learned a lot from this. My question really relates to not the capabilities here, but many of my customers were unable to attend today. The recording that you have on the website, is there a way I could send the recording to some of my customers who might be interested to take a look at this afterwards?
Yeah, Garudis, I'm sure we can figure something out, or at the very least, you can send them a link to the recording. But yeah, get in touch with me, and you and I will make sure that happens.
Okay, sounds good. Thank you.
Another question I have, maybe linked to the first one. If a mill decides to go ahead with an application, does someone from the applications team, do they fly out, or do they work via a local installer or vendor to have it installed, to assist with the programming? How would that work? Because we're obviously global, and so the systems might be applied in different parts of the world. So how is that achieved?
So you're asking how we get the program installed?
Correct, yes.
That can be done several ways. If once the OnGuard Eye is up and powered and has either internet or cellular service, we can do some of that remote. Or, we can, our IT, DCS people can send a thumb drive and have the program loaded there at the mill. A lot of the nuts and bolts stuff is mill done with getting power, cabling, the OnGuard Eye powered up and ready to run.
I would also,
yeah. Go
sorry,
ahead, Tom.
Scott. I was just going to say, I would also add to that Solenis has regional pulp applications people in every region. And so typically they work with the local site sales rep to coordinate, the ordering, delivery, installation. So the local site sales rep would kind of organize everything. And then, with periodic visits from applications as needed throughout the setup and startup process.
Yeah, because part of the background for the program is doing a pretty good data pull to sort through that to make sure, we gather the data and get averages and highs and lows to make sure, everything fits, in the program. So that would take some, applications folks to look through that too.
Okay, 100%. Thanks.
Anyone else? Great questions so far. Keep them coming.
So in terms of the communication with the DCS, would the operator be putting this in like Cascade, and it's Cascade program, and then it's getting the set points getting cascaded into it?
Yes. It depends on how you have your pump set up. Most of the time you have you got a manual where you just set it to a certain percent. You got an auto where it holds a set point. Then Cascade, or remote, where it turns the control over to the on-guard, to the algorithm. But yeah, I mean, that's, kind of your three modes of operation.
Yeah, there's nothing about this that would change the feel necessarily for an operator. The only difference would be that if they're running a control program now, when they go to auto, instead of pulling set points from their internal program, they would basically be pulling them from the iController, from the program.
Yeah, so the iController, when they go to Cascade or remote, the iController sends the set point to the DCS if the DCS is controlling the pumps and says, hey, run this pump at, this mount, and it'll do it. Or if the, iController is controlling pumps, it'll go all to the iController, and it'll pull the info, calculate the set point, and, control the pumps that way. That answer that?
Yeah, thank you.
Okay.
Hey, Tom and team, I have another question. How would you contrast the SmartWash capability and program to what's available in the field comparatively? I'll give you an example. There are companies that offer the inline measurement of entrained air, for example, and claim that automating measurement of entrained air and therefore closed loop control the defoamer flow. And that's been advertised quite a bit. And how would you contrast that plus or minus between those two systems?
Garudis, what our algorithm does is actually take the physical KPIs that are going on out in the field, and how the system is responding to each input and adjust each defoamer feed independently. With some of these other ones that are looking for entrained air or something like that, it's one measurement to control every pump. And, as you know, all entrained air isn't equal. It's whether it's fine bubbles, big bubbles. If it's big bubbles, it's coming out of the system and it doesn't hurt you. So, are you going to make change in your defoamer without knowing how your washer's running, based on one input? Ours looks at, it doesn't matter if it's, high, low, whatever, it's how it affects the washer is how our system responds. Harold, do you want to follow up?
Yeah, I would just say that it's, those things like that, the entrained air are looking at a single point, and there are certainly times where it's a valuable input. And we have the capability of incorporating those inputs into these controls. But that single input, as Scott was mentioning, doesn't consistently mean that the washer operation is going to change and that you need to drive that entrained air level to a certain point for the washers to run well. So instead of using entrained air as a predictor that something might happen on the washers, we're actually monitoring the washers to see what is happening. And if the washers are running fine and don't need more defoamer, we don't add more defoamer, no matter what this other indicator says might happen. So we're really looking at the performance of the process as opposed to relying entirely on a potential predictor of performance, if that makes any sense.
Yeah, thanks. Thanks, guys.
Hey, Garudis, this is Marty. I'd also add that one of the one of the major thought processes that went into developing this particular approach was the ability to integrate it with any set of controls the mill might have for their own purposes. So if they've contracted with a control supplier to do APC or whatever on their washers, or if they're doing some sort of in-house advanced process control on that washer train, we didn't want to be competing or interfering with that. We're simply reacting to the current process to control the defoamer pumps, not dictating shower flows or dictating filtrate tank levels or anything of that nature. They can still implement their own control scheme on their washer train, and this system would integrate with that almost seamlessly as it continues to react to the current process variables.
Thank you.
Thanks, Marty. For those who don't know Marty, Marty is our North America regional market manager for Pulp. So thanks for the additional detail, Marty.
Yeah.
I think I cut somebody off. Was there another question?
Sorry, this is Kevin Morris. We've ordered an eye controller and have a project to do here at Resolute Calhoun, but I'm trying to figure out really how we could best use this. They have a very good process control system, and if they can get everybody in line to move in the right direction, and we're working on that. So by adding vat level controls and by using the defoamer controls to ramp up on production rate, these are a lot of things that the eye controller, based on the algorithm being developed for Resolute Calhoun, are going to do. But yet they're already really being incorporated in the process control side of the DCS. So I'm kind of interested to see how the eye controller, if it just fits a market niche to say, hey, we're doing something here, and we can say we've got something competitive to Buckman. Or is it really more advanced than what we can do, what they can do in the DCS controls? If we add the production factors into the DCS controls and things like that. I guess my next question after that would be, the eye controller is not like optics. It's not where it can learn from the system and improve. What I understand, is there an optics initiative for this area? I'm interested in your comments on that.
I think as far as the optics is concerned, that has been a topic of discussion, but it is not a current focus with all the other optics projects that are going on right now. And as far as the controls, I wasn't quite clear on the whole question, but you know, there's nothing that this program is going to do that is going to change the mill's control strategy. We're going to support the mill's control strategy with the program. And of course, anything, we're pulling data from the DCS. If the mill elects to build a control strategy within their DCS, that's always been available to them. I think what we bring is a knowledge of defoamers and what they can do and cannot do, as well as a pretty significant process knowledge to know how to create an algorithm that's going to be most effective. So, you know, we're using their data. So obviously it's not like we're bringing in something, you know, behind a black curtain. This is a program that was developed in-house with Solenis's expertise. And if the mill has that level of expertise, then there's nothing to stop them from creating their own algorithms and their own control strategies.
Yeah, and Kevin, we do a little deeper dive into, you know, observing the system and, you know, getting the clues from how the washers are running, you know, to make the adjustments. It isn't just, pounds per ton and ramping up and down with production rate.
Yeah, you take a pretty simple situation, Kevin, where you're, say, a vacuum drum washer, where you're trying to control vat level based on drum speed while holding, vat dilution at a constant ratio. That's a pretty common application, but as I continue to ramp up production, there's going to come a point where that drum's going to you're going to either run away or you're going to have to back off on production. We're adding an extra layer here, whereas that drum speed maybe speeds up as it's trying to control that vat level. We can do something with the defoamer that maybe slows it down to keep it within range. So it's not interfering with their controls. It's simply a complement to it.
Okay, I appreciate that, and I just like hearing your comments because we're all in this and we're moving forward with it and working with Dr. Wang and Alex Zhang on the algorithm and moving forward. And I like the idea of putting it on and watching it before you actually get it, in remote or eye controller wise going. So I'm looking forward to it in the aspects is that right now the operators, they like to add defoamer, but they don't cut it back. And when you're challenged on your defoamer cost, that's a bad thing. So having an eye controller that would help bring it back in line is where I see maybe part of the benefit is going to be and help us be more competitive. So I am looking forward to it. I'm just very cautious sometimes as to how this is going to work because operators seem to have a mind of their own sometimes. But thank you. I appreciate this opportunity.
Thanks for the comments, Kevin. You made me laugh with the comment about operators like to add defoamer, but don't always cut it back right away. That's obviously an all too common issue, I think, for a lot of mill sites. So other questions, really good questions so far. So thanks everybody for the comments and the participation. Any more? We've still got some time left. But just as a reminder, again, if anybody wants to have a more detailed conversation about this, please feel free to reach out to me, to Harold, to Scott, Marty Hoskins. If you know Marty, you can reach out to him as well. We are happy to, or your local Solenis sales rep, and they can connect you guys with us, and we'll be happy to have a more detailed conversation. So I guess I'll reach out one more time for more questions before we wrap this up. In that case, I will thank everybody again for the participation. That concludes the webinar, and everybody have a nice rest of your day. Thanks, everyone.
Thanks.
Thanks, guys. Good information.
Thanks, everyone.
Thank
you.
you.
Everybody.
Bye.